Good morning, friends. Today, I, I just want to make a video on how to write the differential length elements, differential surface elements, and differential volume elements in electromagnetic fields. Because the reason why we need to know how to write the differential length, the differential surface, and the differential volume. The reason is, in order to find the line integrals, surface integrals, and the volume integrals of different quantities, we need to know how to write their differential elements. Because if you observe in electromagnetics, we need to find these things first. In order to know the current enclosed, we need to find line integral of h dot dl. Or in order to find the work done or the potential difference, we need to know E dot dl bar. So in this way, we need to know the line integrals, as well as in order to know the flux leaving a closed surface or a surface which is open, we need to find d dot ds, surface integral of d dot ds. We need to find this integration in order to find the flux leaving a surface. In order to find the current according to Ampere's law, we need to find the line integral. Similarly, in order to find the charge inside a closed object or inside a closed volume or a volume, the charge contained in a volume can be found when you know volume charge density and if you know differential volume. So we can call now dl bar as differential length, means a small length out of the entire length or entire the path. Similarly, ds bar as differential area. Why we are calling it as a differential area? Out of a total area, I am considering a small bit of area. Hence, it is called as a differential area. And dv. dv is a scalar, whereas dl bar and ds bar is a vector. Later we will see why we are making dl bar and ds bar as a vector and dv as a scalar. So dv is nothing but differential volume. Differential volume is nothing but a bit of volume out of the entire object. For example, I have a sphere. A solid sphere. Out of this sphere, I considered a small portion like this. Then the volume of this small bit is called nothing but differential volume. Similarly, differential area. Out of an entire sheet, I am considering only small portion. This is called as a differential area. Out of the entire length, I am considering a small length, and this is called as differential length. So in this way, we can differentiate between the differential length and the total length or total path. The reason why we need to know how to write dl bar, ds bar, and dv for different coordinate systems is to find the line integrals, surface integrals, and volume integrals of different quantities. So in order to find this, we need to know the differential elements. So there is a procedure in order to write the differential lengths, differential surfaces, and differential volumes in electromagnetics, which you can easily understand if you know how we have written the differential length. First, we will see differential length. How to write for a differential length. First, we will see that. But here, differential length in Cartesian system contains three variations, because in Cartesian systems the variables or the coordinates are x, y, and z. Hence, the differential length can be in terms of dx, dy, and dz. First of all, we will see how to write them. So we have made a video on how to represent a point in a Cartesian coordinate system. Please go through that. Please go through that video in order to understand how we represented a point in different coordinate systems. So x, y, z. You can consider this coordinate system in three ways. This as x, y, z, or you can consider this as x, y, z, or you can consider this as x, this as y, and this as z. These three are the correct way of representing the coordinate systems. So first I'm considering any one out of this. So as I'm comfortable with this, I'm using this way of representing a three-dimensional coordinate system. Now observe, DL bar means differential length must contains both the three directions. It depends upon the path you are selecting. First, I am considering a path like this. This is the path I am considering from the origin. If you observe, it is in a three-dimensional plane. It is not like this, right? It is not like this. It is like this. So what we need to do is, this DL bar contains all the three coordinate systems. So from the origin, I have the path. So I need to start from origin. I need to move a distance of dx units in x direction. Later, I need to move a distance of dy in y direction. Later, I need to move a distance of dx. This is the movement, dz. See, observe here, I have moved a distance of dx in x direction like this. First, I have moved a distance of dx like this. Then I have moved a distance of dy in y direction like this. And I have moved a distance of dz in z direction. So first movement is like this, second movement is like this, third movement is like this. So the vector joining this point and the origin is called DL bar. See, this vector joining the origin and this point is DL bar. How this vector, though it is looking like it is in a two-dimensional plane, but actually it is like this, because I have moved a distance of dx in x direction front, and like this I have moved. First I have moved like this, then I have moved like this, then I have moved. So you will have dx like this. If we have both the three variations, how to write DL bar? So DL bar is equal to dx ax bar. Dx ax bar is a vector which is in x direction and having the magnitude of dx. I need to add this vector to another vector. What is that vector? dy ay bar. Why dy ay bar? After this point, I have moved a distance. See, I followed these directions. These are the three vectors I need to add in order to get this vector. It is like vector summation. So I have moved through ax, means I have moved in the x direction for a distance of dx and the y direction for a distance of dy, as well as in z direction for a distance of dz. So we got dx ax bar, dy ay bar plus dz az bar. It is very simple to understand and very simple to remember also. And this forms the basis in order to find the DL bar for cylindrical system as well as for spherical system. This is DL bar. So this is nothing but the differential length in Cartesian system, which contains all the three directions. For example, how to modify this DL bar for our problem. Our problem may contain the three coordinate systems or may not contain the three coordinate systems. There is no guarantee. The variation may not be in three dimensions. For example, I am considering another coordinate system. Let us take this as x, this as y, and this as z. Now observe, I have placed a conductor in x-axis. Means I have placed a conductor along the x-axis, and this conductor has some length L. This conductor has some length L. Now, how to find the length of this vector, or sorry, the length of the conductor? In order to find the length of the conductor, the differential length that we need to consider is dl bar as dx ax bar only. Because from this point to this point, there is no variation in y. Because y value is 0 from this point to this point. Similarly, z value is also 0 from this point to this point. So, in between the 2 points, there is no variation in z. Hence, dz value is 0 for this part, for this problem. And from this point to this point, there is no variation in y, because y is 0 here and 0 here. There is no variation in y, hence dy is also 0. You have only the variation in dx, hence I am writing dl bar as dx ax bar. In this way, you can write dl bar for any, if the quantity is varying in 3 dimensions, we need to consider all the 3. If the quantity is varying only in only one direction, then you need to consider this. In this way, you can write the dl bar for any type of quantities in Cartesian system basically. If you understand how to write dl bar in Cartesian system, you can easily understand how to write dl bar in cylindrical system as well as in spherical system.